All right, so now we're going to talk about rate of change. Okay, I'm going to give you a second to read through this, and I'm going to have you maybe take a look at something that might look familiar. So, give you just a couple of seconds and then we'll talk about it. Okay, so I'm hoping that this right here that looks familiar to you. So it should look like the slope formula that we have already talked about. So rate of change is just a fancy way to say the slope formula. So why did we have two different terms? Well, we talk about rate of change in terms of a specific situation. Slope is a generic situation. So slope is for generic, rate of change is for specific. Okay, so here's a specific situation where we might use rate of change. So the number of pedestrian fatalities in the United States declined approximately steadily from 4,795 fatalities in 2006 to 4,092 fatalities in 2009. They give their source. Find the average rate of change of the number of pedestrian fatalities. Okay, so you might be asking yourself, well, I don't even know where to go from here. So here's what you want to do whenever you see problems like this. They are telling us find the average rate of change, right? So that means we know that we're going to use the slope formula. All right, now the key here is how in the world do you figure out your 2 points that you're going to use to find your x sub 1, y sub 1, x sub 2, y sub 2? Here's what you do. So it says here from 4,795 in 2006. Now remember, we've already had the discussion that anytime time is one of your variables, then that is most likely 99.9% of the time going to be your independent variable. So 2006, sorry, that 6 looks funny, is my x coordinate of my first point, and with 2006 comes 4,795. My next point is the next set of data. So I've got 2009, and what goes with 2009? 4,092 fatalities. Okay, so I'm going to let 2006 be my x sub 1, 4,795 be my y sub 1, my x sub 2 is 2009, and my y sub 2 is 4,092. So I've got 4,092 minus 4,795 over 2009 minus 2006. Now it's just a matter of doing some math. So let's take a look at this. Okay, so whenever I subtract 4,092 minus 4,795, I get negative 703. 2009 minus 2006 is 3. And then whenever I divide that, I get approximately, notice I'm using the squiggly equal sign, negative 234.3 or so. And so what does it mean in this case? It means find the average rate of change of the number of pedestrian fatalities. The nice thing is that they seem to be going down. So the negative sign indicates that the deaths are declining, and they're declining by approximately 234 deaths per year. Okay, so now let's take a look at this one. The total cost of 12 karate classes and an enrollment fee is $158. The total cost of 20 karate classes and the same enrollment fee is $230. The charge per class is the same, regardless of the number of classes for which you pay. Find the rate of change of the total cost with respect to the number of classes. Okay, so let's make some ordered pairs here. So you need to understand which one is your independent, which one is your dependent. Well, think about this. The cost of your classes depends on how many you take. So the number of classes is your independent, the cost is your dependent. So I've got 12 classes and $158. There's one of my ordered pairs. The other ordered pair is 20 classes and $230. So I'm going to let this be my x sub 1, y sub 1, x sub 2, y sub 2. So we're finding the rate of change with respect to the number of classes. So again, using the formula, I am going to do the slope formula. So 230 minus 158 over 20 minus 12. So I get 72 over 8. And now I don't need to use the squiggly equal signs because this actually I don't have to round at all. 72 divided by 8 is 9. So what does that mean? It is $9 per class. Alright, so take just a second to read through this. It really does make a lot of sense. It's talking more about the positive slope and versus the negative slope, and so just take a second to read through this. I'm also going to give you a second to read through this page as well. Okay, I'm going to give you just another second to read through this. It's so much easier to explain these things in an actual problem. Okay, so let's take a look at this problem. The temperature at which water boils, the boiling point, depends on your elevation. The higher you are, the lower the boiling point is. At sea level, elevation 0, water boils at 212 degrees Fahrenheit. The boiling point declines by 5.9 degrees Fahrenheit for each 1,000-meter increase in elevation. Let B be the boiling point in degrees Fahrenheit at an elevation of E 1,000 meters. Now, there's a way for you to look at this and say, oh, hey, I know that my slope is negative 5.9. I am a person who has to see 2 points, and it has to prove to me that the boiling point or that the slope is negative 5.9. So here's what I do. I create 2 ordered pairs. So I've got 0, there's my elevation, and my boiling point at sea level is 212. Then I'm going to talk about 1. Now, why would I talk about 1? I'm going to say that my x's are in thousands of feet. That way I'm not dealing with huge numbers. And at 1,000 feet, I know that my boiling point is 5.9 degrees less than 212. So my boiling point would be 206.1 degrees Fahrenheit. Okay? So now I know that I have 2 good points, and I can prove to myself that my boiling point is negative 5.9. So I would do my slope formula again. All right, there's my slope. I know that my slope is negative 5.9. Now, the next page, it's telling us, is there a linear relationship between E and B? Yes, there is a linear relationship between them. If so, find the slope. Because that changes exactly 5.9 degrees for every 1,000 feet, then that means that there is a linear relationship. If it went down 4 degrees in some places and 3 degrees in others, then that does not indicate a linear relationship. But because it's exact for every 1,000 feet, it is a linear relationship. Now they want us to find an equation of the model. We're not going to do step number 3 here. So I'm going to go back. Alright, so I know that this right here is my m, or my slope. Now I've got to figure out what is my b, or my y-intercept. Remember, your y-intercept always occurs when x is 0. Do I have a point where x is 0? Yeah, I do. So I know that my y-intercept is 212. So the equation of this line is y is equal to negative 5.9x plus 212. That's my equation of my line. Okay, so let's hurry up and take a look at question number 4. Mount McKinley, the highest mountain in the United States, reaches 6.194 thousand meters. What is the boiling point of water at the peak? Alright, so let's take 6.194, this number right here, and let's plug it in where we have our, let's see here, our y's are our elevation, no, that's our boiling point, so our x's, so we're going to put it in for x, so y is equal to negative 5.9 times 6.194 plus 212. The 6.194 is an elevation, that's why I put it in the x position. So on my calculator I'm typing in negative 5.9 times 6.194 plus 212, and I get approximately y is equal to 175, I'm going to use the squigglies instead, degrees Fahrenheit. So that's approximately where water boils at the top of Mount McKinley. Alright, so let's take a look at this model. Okay, so it says yogurt sales in the United States are shown in the table for various years. Let S be yogurt sales in billions of dollars in the year, that is T years, since 2000. A model of the situation is, and they were nice enough to give us the equation that they used for this data. So I've got year 1, because remember it's since 2000, year 3, year 5, year 8, year 10. Okay, so it says here, yogurt sales in 2001 were about $2.3 billion, 2003, $2.7 billion, 2005, $3 billion, and so on. Use a graphing calculator to draw a scattergram and the model in the same viewing window. Check whether the lines come close to the data points. So let me show you that. Okay, so the line comes from this equation right here. The dots that you see on here, these little squares, those are the actual data points that are in that table. And so yeah, that line is very, very close. It's not exactly, but sometimes in real life you don't get exact linear relationships, but this is really close and really good. So then in question 2 it says, what is the slope of the model and what does it mean in this situation? Well, they tell us the slope. The slope is 0.19, which is about 19 over 100. Okay, so that means that the slope is about $0.19 billion per year. That is craziness. So yogurt sales are increasing by $190 million per year. Okay, so the next question says, find the rates of change in sales from one year to the next in the table. Now I'm going to show you this because they've already done this for us. What they did is they found the sales in between every single year. So let me show you that table. Here it is. Okay, so your y's over your x's, change in y's over your change in x's, change in y over change in x. And this is what they came up with. 0.2, 0.15, 0.17, 0.30. And so the rates of change are pretty close to $0.19 billion per year, which tells me that 0.19 is probably a pretty good slope for this. Now, it's not exactly, but they're pretty close. You're not seeing anything that's way far off. So, not too shabby for the slope on this. The next question says, what is the s-intercept and what does it mean in this situation? So, let's look at that. The s-intercept, remember the s is our sales, so it's this one. And we're looking at our intercept, okay? So let's take a look at that. Oops. So the s-intercept is 0 and 2.09. Now, did we know that based on this? Yes. This was our s-intercept, 0, 2.09. Okay? So what does it mean? It means that yogurt sales in 2000, because remember 0 represents the year since 2000, were $2.09 billion. Now the last question says, predict the sales in 2018. So we're going to put 18, not 2018, 18 into this equation. Right here, and we're going to see what we get out. So whenever we put 18 into the equation, we get out 5.51. That means 5.51 billion. So they're estimating that in 2018 the yogurt sales will be $5.5 billion. Okay, for this last problem, we are going to find an equation of this line. Okay, so check out what's happening in between every single y here. 15 to 9, it's going down by 6. 9 to 3, it's going down by 6. 3 to negative 3, it's going down by 6. Negative 3 to negative 9, it's going down by 6. Look what's happening to your x's. It's going up by 1, up by 1, up by 1, up by 1. So I've been saying all along, change in y's, that triangle means change, or delta, change in y over change in x, and my change in my y's are a negative 6. My change in my x's are a positive 1. So that gives me a slope of negative 6. Now the only other piece of information that I need to know in order to write the equation of this line is I need my y-intercept. So I need my b. And whenever x is 0, my y is my y-intercept. So I have enough information to write the equation of this line. There we go. We're done. Alright, I hope this is helpful to you. I will see you later.